Right, so everything is run. Okay, so it's good. So just uh, for logistic, so we have to separate today's session to two because Zoom only give me like 40 minutes for one session. So I have created both link over there. So please, I will stop at about 10:40. Then we will come back again at about 11. So you can take like 20 minutes break in between. And also I will switch my topic. Right, so this is the first thing that I would like to remind you about the time and also how to join later on, just in case that, yeah, the session over and you cannot continue anymore. So we will switch to the next one at 11. Right, then also I have shared the slides that I show on the screen. So if you, so if you go to, okay, let me close this. So if you go to our website, this thing is not going to like hide it. Okay, so over here you can see this slide, which is if you access, you will get something like this. Okay, this is annoying. Can I like, yeah, okay, okay, this method. Okay, private message. Yes. And where is my chat? I'm searching where's my chat. I am not sure. Is it here? Okay, it doesn't matter. Right. Okay, so over here, so if you click on the class material slides, then you can see. So I have shared everything here that you can refer uh, along the way. So just in case that you can't see the screen, but yeah, don't worry about that. Also, I will record this session. I don't know now which one is recording. I think it's on the screen. So I hope like every time after the class, I will keep the record, upload to somewhere, maybe YouTube, and then I will post it on the site. So I'll embed here so that you can see the rerun, or just in case any of your friend or colleague or whoever that missed the session, you're still able to see the rerun of the whole thing. Okay, so basically this is all the logistic that I would like to explain here. So I hope no problem. So I will run this for the following next few weeks. Every week, hopefully I can keep the same timing like Wednesday morning and then 2 hours and every week I can go on. But now, as everyone know, like the situation is very uncertain. So along the way, I'll keep everyone informed. But I try to stick to this timing. So every week I'll spend 2 hours and tell you something. Okay, and I hope you can also like join us, right? But don't worry if let's say you miss something or you can always see the rerun. I have the slides and also the video there, so everything will be fine. And you, if you're interested, you can always find back the materials that you need. But I will encourage you to join our session so that we can have more sharing. Okay, right. So these are the few things. Then the next thing is while waiting for the rest to come in, I would like to share this thing to everyone. Okay, let me see. So it is like a attendance list. Okay. Okay, so how am I going to start a new chat? A new chat. By clicking a chat. Okay, I have no idea how to do this. New chat and it's true, right? How to start a chat for all of you? Okay, yeah, I found. Right, so it's not this one. Is it this one? Can everyone see? Okay, oh, is it? No. Okay, I try to find a way to send a chat to everyone. Okay, is it this one? This is your personal space. No, not personal space. Oh, okay. How am I going to chat with all of you? Anyone know? Okay, how to send a chat to every of you?
Is it at the bottom?
Is it at the bottom? Oh, okay.
Yeah,
This thing.
beside the share screen, there's a chat.
Oh, okay. So
Yeah.
this one, there's a chat.
Yeah.
Chat. Okay, chat. Right. So okay. So this one. Right. Ah, good. So everyone actually like sending something, which is good. Okay. Right. Good. Okay. So I will send this. Okay. Please keep this. Oh, I think this is private. How to? Okay. No, not private. Everyone in the meeting. Sorry. Again. Okay. So okay, right. So I sent a link of a Google spreadsheet. So this spreadsheet, the purpose, okay, let me explain, is first I would like to get some attendance so that I know like who have joined, and also you can put some remarks uh, if you like, okay? And also like if you have any problem, you want to feedback, for example, like the sound is not clear and everything, you can put down the remark after this so that I can remember what happened. And more importantly, is like your name and then your contact, okay, your email, right? So why I need your contact is, yeah, I hope this session can actually bring up us together as a community under RoboCup at Home Education, so that we can plan together like what to do in future together, right? So please appreciate that you can put out your name and also your very like general information like your profession, affiliation, and also your email so that I can reach you. Right. So this is the first thing. And also the second thing is like I understand that we have people come from everywhere. So we need a platform for communication after this, which is not live. So I think the best way that I can provide now is maybe WeChat is, sorry, not WeChat, WhatsApp is a bit private. So we can add later in our WhatsApp group privately later, no problem. But for the general public, I will say that please like our Facebook page. And also I started a group, so you can join our Facebook page. There is a group there. So I have created that for quite some time, but it's not active. So now I think maybe we can use this platform for our communication, daily communication. Later on, if you have questions you want to ask, or the community, maybe I can't answer you, but other people can answer you, or you have anything you want to share with the groups, all right? So it's an open sharing knowledge platform. So I hope, yeah, please like our page and also like join the group so that we can have communication over there, right? Okay, so where is the Facebook page? Okay, so let me show you. So this is the Facebook page, okay? Facebook RoboCup at Home EDU. Later I will share the link, don't worry, okay? Then yeah, this is to visit the groups, and then we will do something, okay? So I don't really like update it frequently, but hopefully after this I can have more time since I'm staying at home most of the time, so I have more time to keep it active after this, okay? Right, so please join and we can communicate. All right, so I think I've spent 10 minutes for all the logistic thing. Okay, let's hop back to our content. Okay, so now go back to the screen. So I would like to start my session. So I only have about 30 minutes, so it's very brief. I try to, but this is annoying. Can I like, there's no way I can hide this. Okay, anyway, right. So first, a brief introduction about myself. So I'm Jeffrey. So I think most of you know about me, but just in case like you're the first time join this session and heard about this, come across the link and so on, or you are asked by your supervisor or whoever. So I'm Jeffrey, so you just can call me Jeffrey. So currently I'm an associate professor in Nankai University, China, but currently I'm under the MCO, I'm in Malaysia. So I'm a Malaysian. And from the list, you can see like I graduated from University of Tokyo for my PhD quite some time ago. And then I'm working as a researcher and also as a professor, sorry, as a lecturer in university. So I'm working on research and also lecture teaching related to robotics. Most of the time you can see the place that I work is related to robotics. Okay, the labs. And also I list down some professional services that I do is actually to show you my, how to say, part-time hobby, but not really hobby because now I get very serious about it. So that's why I'm working on the class. So I am committee member for RoboCup Federation or at home until last year. Then I started this RoboCup at home, started 2015, and now I'm still working on. I also still active in RoboCup Japan committee. I spent a long time over there. So organizing, and I also like the WRS committee. So I organize a lot of this kind of robotics and AI related competition. And that is how I come up with the topic today to talk to you. Right, okay. So I just want to run this faster. Okay, so today, or before I explain like the overall, like how I'm going to run this class, because this class is going to run like maybe for the next 5 weeks, content already planned. I think I might run until like for the following, like until like 7 weeks or 8 weeks. It depends on the situation, but I will try to, but I have the content because like this content is prepared based on my materials from my university and also my research work for all this time that I have been working on. So I would like to arrange it so that you can we can share it in this online session. Okay, so let me start the story with service robot. So to me, service robot is AI plus robotics. Okay, right, and it is very different from a lot of robots that you may imagine. Okay, because a lot of you like in mind, maybe you have the mind of like you thinking robot in the factory. You also maybe think like robot in the movie. Okay, so but the one in the movie maybe is quite close to what we are talking here, but maybe not that sophisticated yet. Okay, so I show this video. I always start this with my class. So I put this video. Okay, let me see if I can. Okay, it's quite lag because I also do the recording at the same time. Okay, never mind. Just leave it like this. Okay, so oh sorry. Okay, okay. So this is okay. Never mind. Okay, so why I show this video to you is the purpose is to tell you that service robot require a lot of AI. Okay, which is very different from other robotics disciplinary because it is actually deal a lot with human. And you can see the robot in this video is actually not designed to have this kind of operation actually, because as a Roomba is for cleaning the floor. Okay, but in this video, it is not about cleaning the floor, but interact with the kids. So what I want to say is the robot that we are talking for this coming few weeks is all about how to build the next generation of robots that is going to be living in our environment. And this kind of robot require very high intelligence in order to do so. Okay, why? I will explain following. Okay, so just come back to the reality. So these are the few examples that actually this slide I have created this slide a few years ago. So the photo is a bit old, but that is the state of the art during that time, like 3-4 years ago, for service robot. So you can see service robot have a lot of variation, okay, from hospital to home to public environment to like serve the public and so on, and also for entertainment and also for education and so on, and child and also healthcare, right? But maybe when you look at this all these robots or the photos, you feel like it is actually quite far from you, right? It is like maybe still in laboratory and it's quite for future. Okay, so a lot of people think that service robot is actually quite not in the current practical way yet. Okay, but I have the next slide. Okay, so this slide is the first point that I want to point out why I want to start this class or work on this research on service robot is because I feel that service robot actually have a lot of potential and it is actually come to our world very, very soon. Okay, so I purposely put this video that is very popular nowadays in social media that showing what the robots have been used for the current COVID-19 issue, right? So we can see like we have, oh, how come it's not running? Okay, so I hope it's running. This is not running. Hope it's running. Okay. Okay, never mind. So I'll try to sort out the issue later on. But this video or this slide, I want to show you like there are actually a lot of real example have been showcased. Okay, and also this kind of application is actually very different from industrial application. So we don't actually design robot just for production in factory anymore. And in fact, robot is working out from the factory, coming into our environment, whether it's in the home environment to assist the elderly, to take care of the children, or we have this robots that recently play a very important role in terms of like when we have this social distancing, isolation. So we are asking robots to, for example, deliver the food for us, deliver the medicine, and take care of a lot of things that human can't actually present personally, right? So these are the things. So I have a few examples. So this is all about the one fighting the virus currently. We have, this is not running, I don't know why. Okay, and then this one, yeah, this one is for the restaurant. So robot that used in restaurant, I think that one quite a lot of people have been heard about it. Okay, so this one is about helping the elderly, right? So first is like what the message that I want to show you here is robotics and AI literacy is getting very important, and it might getting very critically important very, very soon. So which means, for example, maybe in our generation, these things are still very futuristic, but maybe down the road, 20 years, 30 years, these robots maybe is practically exist in our daily life. And if we are still not able to know how this thing work, we might not able to become the workforce later on, because everyone afraid like AI will take away our work and so on. But I feel that if AI getting more useful later on, it is very, very important for us to know what is AI and how it put on robotics to solve real world problems. And this will be maybe very important job requirement later on. Maybe not for our generation, but the generation after this, like for our next generation, they need to know and they need to study robotics and AI, maybe start from young age. So this robotics and AI literacy is something I feel that we maybe you're not aware, but I think it's very important. And that's why I started this research work and also work on this. And I feel that the education is very important if, let's say, we want to increase the literacy among the general public, not just for research. Okay, so this is the first thing. Then the second thing is like you might say, okay, we have a lot of robotics class, AI class currently, not just in university, but we also have a lot of this kind of thing in primary or high school, right? You might say, okay, yes, for example, you have a cousin, your brother, or whoever that joined RoboCup or anything that use the Lego Mindstorm, like, okay. So I showcase you two video. This is a real one, real case. So on the left is the RoboCup Junior Australia in 2014, showing the rescue for junior. So that is the rescue competition for junior. Junior means anything 19 years old and below. Then I show you on the right-hand side is the rescue, okay? So the same category, the rescue robot for university, which is the major league in RoboCup. So that is a RoboCup 2019 from a team from Kyoto University. Okay, so why I want to show you this is I want to show you the second problem that I feel what I'm doing here is important. Okay, so the second problem is I found that currently we have a lot of robotic class, AI class, and everything for children in comparison to what we are doing in university when we try to tackle the real world problem. So on the right is actually very close to real world problem. We try to have very similar standard of, for example, like how we can simulate the terrain of the real disaster area and so on. But you can see on the left hand side, it is a line follower, flat surface, black and white, which is a very conceptual problem. Okay, so why this different is because like it is very understandable that we need to have such simplification for junior, but the problem lies on we actually don't have a bridge in between. So which means I actually handle this case myself in my class. I teach second and third year undergraduate. So they are like 20 plus, which is right after the junior, right? So which means right after the junior, that is the skill set that been, how to say, they can acquire through this kind of activities. But the problem is when they just jump to age of 20 and they come to college and suddenly you say, okay, from the left, you're supposed to build the robot for the right, for the robot that appear in the right-hand side. So it's a very big jump, okay? It's a very big jump from line follower to like autonomous slam navigation. There's nothing in between. And maybe on the left-hand side, you are still using a graphical programming language and maybe like, yeah, you put all the blocks together. And on the right, suddenly I give you a Linux machine with ROS, everything black and white coding. So it's very hard for the transition. And a lot of cases fail, right? And also that is for the robotic side. Another point of view, for example, like on the AI side. So now AI is a booming, but a lot of AI focus a lot of very complicated things. Oh, sorry. Are you sure? Is that? No, not yet, right? Okay, so 40 minutes, so I should have time, hopefully. Okay, so I need to cut it short so that I can finish in another 10 minutes. So the second problems that I want to stress here is like we need to have something in between to link between whatever fundamental robotics and AI classes that currently we have for children in order to bridge them to really solve the real world problem that we are doing in the university, this is what I feel that is lacking. And this class, I'm tackling this problem by showing you what is the immediate step. Okay, right. So the third things that I want to say is the distance from the lab. So in real scenario, in reality, so how far is the current technology availability for the mass? I'm not talking about research. We have a lot of funding for research to do robotics, advanced AI application development. That's very true. But the problem is how to actually make all this technology available for the general public. Okay, so I show you this graph. So what this graph means is like, okay, this is a Lego MyStorm or Lego EV3. I'm not so sure. It's the Lego robotic system. So it's about USD 500. So it is affordable, but unfortunately, it is actually solving very conceptual problem. All right. So like what I say just now, is a robot belongs to the left-hand side. Then we have something very practical, which exists for more than 10 years, which is but I mean just upgraded to unlimited. Are you sure? Okay. Is it? Okay, never mind. Right. So okay, never mind. I don't know what happened, but okay, let's continue this because I will cut everything after 10:40. Okay, so we have the Romba, which exists in the market, very successful service robot business, because like a lot of service robot business actually died off recently, currently, but this one remains strong. Okay, but the problem is like we can see the price range is very affordable. I mean, within something that we can actually accept. So it's like 1,000 USD, or maybe it's in the price of a laptop or price of a handphone, right? Or maybe slightly more expensive because like it gives you more functionality. Okay, so this is very comfortable, but the usefulness is still very limited as compared to the very intelligent or service robot that we imagine, especially in the movie. Like it can really talk to you, it can understand everything, it can do everything for you. Very far. Okay. This one, for me, I feel like it is just a very intelligent vacuum cleaner, which is it is a very intelligent vacuum cleaner, but it is not intelligent enough that you can actually feel that it is a service robot for the future, right? Then, okay, 10 years in RoboCup, and we now have some very nice mass-produced service robot platform. So this Pepper from SoftBank. So SoftBank is a big company that they invest a lot. They create this. So, but the price is about 30,000. Okay, this is no longer something very affordable. Okay, because it is more expensive than your laptops. It is as expensive as your car, but it is not as critical as your car, right? Okay, so that's why it comes here. And then we have a very state of the art currently. When if you ask me like what is service robot that currently we have exists and really live up the capability is what we call the PR2. So this is a PR2, and with this price tag, and even this is the discount price for academic. So the actual cost is actually much more than that. And we have something very similar in between here. So something in over here, recently we have a lot of company building robots, but it's within this range. So it's about this kind of price, but give you practicability and usefulness about this. And actually what we're aiming is something over here. This is what we want. Very practical, which is can use for your daily life. You can employ in, retail, in hospital, in school, in home, but something very affordable like a laptop, or maybe price of 2 laptops and so on. But this is very far, still very far. So we're not sure because everyone now is working on this region. Okay, there are a few reasons, and there are many reasons actually why we are still working on over here instead of like pulling down the price and still maintain the practicality. So currently what I'm going to show you is actually a solution or a robot platform with all the software hardware thing that we try to have something like this, but over here. So this is something that I want to show you that what I've been working on is something very practical. Although the practicality may be not as powerful as this thing. That's why I use the platform for education, because like if you use it for education, it is it don't have very high requirement in terms of the reliability. Okay, but more importantly is we can use this thing to have something very similar functionally, but within the affordable range, and it able to generate a function to educate the general public to understand what is AI and robotics, to solve the first thing, the robotics and AI literacy. So that is the things that I want to say. So these are the 3 important points. Right. So I have to cut short now, but I'm going to tell you what happened after this. So we will break at 10:40, which is I have about 10 minutes more to go. So in the second half of the session, which is will start from 11, so I'll introduce you the work that I've been working on. So which means how I actually lower down the complexity of service robot development until the level that is affordable for everyone, because thanks to a lot of open source technology that I can use a lot of very sophisticated, powerful tools. And also thanks to all the 3D printing technology and the price that get low, all the sophisticated sensor, for example, the RGBD sensor and so on, which is not possible to obtain that in that price 5 years ago, but now it become a reality that it is actually a game device and so on. So this kind of sensors is getting cheaper, materials is getting cheaper, development 3D printing is getting cheaper, and then we have free open source software. And this is how I assemble everything together to show you a platform that we can DIY. So I call it service robot DIY. So which means everyone, each of us, within our range, because the price that you put out maybe is like a price of 2 laptops and so on, which is laptops is something that affordable now, right? So I want to show you how you can do this thing, so that my purpose is to outreach this thing so that everyone can play a part, can be involved in this service robot development. So that's my purpose. But come back to the reality, because now through this class, I have to do everything online. So which means we can't actually have a lot of, and I cannot expect you to have the robot with you now. Okay, of course, I currently hold a robot with me, okay? Small enough to fit into my luggage so I can carry it all over everywhere with me. But I will try to design this class to talk about how you can build it with whatever materials you have in your house. So for the first maybe 3 to 5 weeks of class, what you need is just a laptop, okay, with mics and speaker, and we will try to show you the important development tools and how you can develop functionality of service robot in terms of, for example, like speech recognition, vision system, autonomous navigation and so on. But that one I will require some simulation, because like you need to have a model that run around, which is you cannot have it if you don't have a physical robot. So we will use simulation for that. But for speech and for vision, we can still use the real thing, because you have your sound card, you have your camera everywhere, your computers, your phone, and so on. So we can actually do a lot of things for that. So for the coming 5 weeks, about 5 weeks, yeah, we will use whatever resources you have in your house, and I'll show you what we can do to actually develop service robot application, right? Then later on, okay, hopefully everything will clear. We can go back to school, you can access to hardware and so on. Then you can start to like think like you want to gather robots, or like look at my robots, and we can do outreach. I mean, like the real outreach workshops, we can arrange it after this so that you can have a chance to work on the real robot and to see how you can put whatever that you learn over here, put on real robot and see how it works. And yes, this is what I want to show you, is something, the robot that appeared here. I'm going to show you how you can actually learn the technology from the platform that introduced you. Yeah, seriously, you no need this kind of hardware. I mean, like, this is not within our range of, I can't afford this with my pocket money if without resources from my lab. But the platform that I'm going to introduce to you will able to at least achieve about 80% of this. Although not the reliability, you can't use it for actual operation, but we can develop the application. You can learn how the technique, how it navigate, how it interact with people, how it talk to people, how it perceive the environment, you know about face, you know about objects, environment, and so on. And then how you put all these things together on an integrated robot system that you can create service robot application. Yeah. So these are the robots that it's possible for us to develop now, right? It's just that we are not able to build something that really can put on the field to work it out, because not the reliability and so on of the materials. But what important is the education part. Okay, again, I want to stress here is like a lot of people, okay, thanks. Everyone is telling me that we have unlimited time. Okay, so I don't need to be so rushed. I'm not sure. I will try and talk until over 10:40 and see how, whether it cut off or not. I'm not sure, because this is the first time really I work on Zoom, because previously I used on the other platform. So let's see how. Okay, but yeah, I have my materials, so no problem. If let's say it's not cut after 10:40, I will have some Q&A so that you can ask some questions. I need some interaction, right? I don't want to make this thing a single way communication. Okay, right. So these are the things, right? Okay. So let me, okay. Okay, this is good. Okay, so okay, I'm on the schedule now. We actually haven't reached the 40 minutes cap yet. Okay, don't worry. We have about 3 more minutes or 2 or 3 more minutes. Okay, which is I'm on schedule. Okay, so this is the second half of my slide that I'm going to discuss. So how we can start this thing, right? So, and I also hope like this will retain you so that you can come back next week and the following week to follow us. So I will show you, because not everyone, I'm not sure, like everyone comes here, maybe you want to learn how to build robots. I understand not everyone want to build robots, but what I want to stress here is, although you don't want to build robots, but this thing will be related to you, whether you like it or not. If one day this service robot become part of our living, I mean like become part of our inside our living environment, right? So we need to know them. Okay, we need to know them. Just like today, we need to know PC, whether you like PC or not, whether you like your phone or not, whether you like to develop software or not, you will be going to use a PC for your work, going to use your phone for your daily life, and so on, right? So similarly for robots, if let's say go down 30 years, 20 years, 30 years down the road, it will become like very common thing that is going to be around us. We need to know how, and that is the point that I said just now, the robotics and AI literacy. So later on, I will show you what we are working on this RoboCup at Home education initiative. And I will show you a few ways that you can involve. For example, if you are teachers, maybe you can use our materials for the class, because our class, our open courseware is open, is I put on the web and you can use it, right? And we can arrange workshops. For example, like if your student would like to join our competition and so on, yes, right? Okay, so 2 more minutes. I will see whether it cut off or not, right? Then if it is not cutting off, okay, then I will start the next session. Okay, I will start with this RoboCup at home. But before that, maybe I will open. So can we switch back to video mode? Okay, I don't know how. Is it like this? No. Okay, I don't know how to actually put everyone back. Okay, so can I like invite some of you to have some question, Q&A about things that, because originally I plan to continue this thing after 11, which is I will spend another 40 minutes to tell you what we have done and what you can actually join us to work together or to use our materials in your activities and so on. But at the same time, I would like to listen to any of your comment or opinion or any feedback that you have on the things that I just said just now. Anyone? Anyone? Right. So you know I need to take a break from talking, so I open for any question. Right. So you are free. You are free to turn on your mic and let's say something. Okay. And also for me to catch up your chat. Oh yeah. Okay. So for any newcomer, please fill in the attendance sheet. Okay, with your email and so on, so that we can keep in touch. And as a reminder, please like our Facebook page, join our Facebook page group, so that we can have a community that I will use that for our communication. Okay, later on. So I hope like I have a spike of like after this, hopefully. Okay, but from the list we have about almost 30. Wow, it's good. I actually achieved my target, like almost 30 people turn out. I know some you didn't put down your name. Don't worry. Okay, you can still join us even you don't want to put down your name. You can still follow us, and I will record this, and hopefully the recording is okay. So I'll record all this thing and I'll put up later on, upload later on, so that people can see the rerun. Okay, but at the same time, yes, if you have any feedback about the things that I just said just now, the first thing, the robotics and AI literacy, okay? The second thing is closing the gap, the bridging problem between whatever that we have, the robotics education, and what actually required for us to actually catch up before we can actually get ready for the robotics and AI generation that's coming very soon. Okay. And the third one is the reality. What is the distance currently that we have from all the technologies that very nicely done in labs, but how far we can actually pull all this thing and make it a reality or practical for everyone. Yeah, of course, the first thing is in terms of the cost. We cannot imagine, I mean, like we cannot naively think that if we mass produce the thing, it will become very cheap, because in order for something to be mass produced, first it need to have that value. And currently we don't have that much of value. If you compare robots with your handphone, you will choose the handphone anytime, right? But in fact, robot can do much more things than your handphone actually. It's just that we're not able to appreciate the value yet. Yes, anyone? Any question before I start? Yeah, please ask. So apparently, like, it didn't cut off. Okay, so it's
Yeah,
good.
yeah.
Yeah, so I think it's good because, like, yeah, it is more than 30, it is more than 40 now, right?
Yeah,
Yes,
maybe I have a question.
yes.
What are the requirements for the students? Maybe they need more basic
Okay, right.
programming.
Okay, so I actually will explain this thing on next week class actually. So next week class, I will first explain what will be the content of the development, because like next week I'll put a session time to discuss about the development, also in terms of research. So for all the lecturers and professors here that you're interested on the research value, so we actually have a lot of research, because this thing come from research. I mean, like, I work this thing as my research as well, and also for my teaching. So next week we will talk about what will be the possible development that you can do along this classroom, this online classroom. Is so far for the content design wise, I actually only require you, first you need to have laptops that you can use it for development. Development means you're going to install some very funny software, which is like, I will ask you to install Ubuntu and so on, which is you don't use it maybe, right? Okay. So you need to have laptops that you can use it for development, technical development. And then you are willing to learn things that, for example, a new OS, for example, Linux system. So that is something that you might need to get ready. But don't worry, it's not very complicated, okay? So you just need some time to get used to it, right? So you will install that thing on your machine. Then after that, we will put a software framework, we call it ROS, Robot Operating System, but it's not an operating system, but it's a software framework that will put inside the Linux system, inside the PC. Okay, and that's all that I ask from you. Okay, then in terms of your technical competency in order to follow, I try to keep very minimum, because in my class, I mean, like for this online class, because I'm opening up for general public, I try not to go into deep about theories, calculation, mathematics, and so on on all the technology behind. The reason is because first I want general public to have access to these materials first, and also this technology first. I want everyone to start using first, even without knowing what is inside. Because I can show you a very simple example. A lot of us, we use our phone, we use our laptops, we use PC for many years, but how many of us in percentage that we actually know what happened inside? You don't know actually, right? You don't know how the processor and the hard disk and the RAM works together. You don't know what happened in the motherboard and processor and so on. We don't know any of them. So similarly, for robotics, I feel that you no need to know actually from the start what happened inside. You first experience how you can make it work for some to solve some problem first. That's my purpose. So that's why even though you are just a high school student or even primary student, as long as you can understand what I'm saying, okay, in terms of like English communication and so on. So I think I will try to keep everything very simple so that I will. So you don't expect very like, I won't talk about calculation equations in this class. I won't do that, right? And also, a very important point is like later on when you want to start do application, you want to start do development, okay? What you need is programming. Okay, so this is unavoidable. So far, I cannot find another way to replace command line programming yet for this kind of development. I mean, a lot of people also ask me like, are we going for graphical programming or any other programming? I say for the current moment, that is the part that we might still need to depend on conventional programming language. I mean, command-based and command lines interface and so on. So if you know a little bit about Python, okay, so for example, you have experience in Arduino, in Raspberry Pi, that will be very helpful, right? But of course, if you are zero from programming, you might feel a little bit difficult to follow, okay? Because I only have limited time in this online session. I only have like 1 to 2 hours to explain you the code. So that's very, very hard for me to like explain the code line by line to you and so on. So a lot of time, you might need to learn the programming by yourself. For example, like how the for loop work, how the while loop work, why the program. But rest, don't worry about so much if you can't follow and so on, because I will show you how, because I will give you a set of tools. And also I will give you a set of example, which means you just put in, you run, you see the result. Okay, you see the result. Okay, for example, like speech recognition, you put in, you run the code, the laptops, I mean, the machine able to hear what you say. Okay, and it can change to the text. Okay, and you don't know what happened in between, right? You don't know what happened. You don't know how it recognize what is all, what are all the theory parts and so on. You don't need to know all those things. And also, if you open up the source code, maybe you don't understand also how actually it transforms. But it doesn't matter because you are going to use it as a tool. But what you need to do is you need to think how you want to write the program to use this tool. For example, okay, now it's able to recognize the text, the voice into text. Then what you want to ask your robot to do when the robot hear those things. And that is what I want you to learn to develop in this class. Okay, so rest assured, for example, like image processing, very complicated thing, deep learning based image processing, YOLO and so on. You no need to go down and do very complicated thing, but what you need to do is you able to use it as a tool to solve your problem. That is more important thing. For me, it's always solving problem is the priority, not about learning the tools. The learning the tool is actually to help you to solve the problem. So the objective is to solve the problem. If you can solve the problem with simple method, that's even better. Okay, right. So if you ask me, my answer for your question will be that. So you need to have a minimum, some basic about programming. And if you don't have, you're still able to follow, but you need to have some preparation, and also you need to learn by yourself along the way. Yes, any more questions? 10 more minutes and I will start the next session. Okay, it seems like we can continue. I'm not sure if anyone joined the second. Should I cut and go to the second one? Okay, maybe I will talk until 11, then we all switch to the next one. Is it okay? Okay,
yeah, sure.
Just in case someone actually access the second link, okay? Because I really surprised that Zoom didn't cut off this session, okay? So later by 11, I will cut off this session. I will save my video. Then we will, everyone access the 11 a.m. link. Okay, right. Okay, so any more questions? 10 more minutes, then we can start. Or if you don't have question, then I may start by showing you the video now. Okay, it seems like not much. Okay, so if no problem, right, so let's switch to this one. Okay, so I want to show you some video, but I'm not going to show you the whole thing. I just want to show you some part of it. So first thing I want to explain to you is this RoboCup at home. So what is this RoboCup at home? Okay, so you see, RoboCup at home is actually a RoboCup competition that focuses on service robot development. So service robot development, as I explained just now, is like the robots that help you in your house, in hospital, and so on. So you want to build robots. And the unique part or the different that I feel for this at-home competition compared to the rest of the league is we are actually dealing with real environment and real problem. So you can see in at home, the game field is not something that we build artificially or conceptually. For example, in soccer, we have the game field, which is not the same game field as the human using, right? It is a smaller one, and then the lighting and everything, the line, everything is slightly different. Or as you can see, this one may be very close to the real one, but still it's not the real one. But for at home, if later on you can see like, okay, it's very lag if I could, yeah. So these are all very conceptual simulated environment. But at home, it's stressed on solving the real world problem, which means you can see later on in the video, we have this game field, which is we have something like a model house. So we use real furniture, sofa, table, and then we don't define, for example, this. So you can see the table, the carrot, even the carrot, they are all real thing, right? Real thing, right? So it follow real human, okay? It's not simulated, it's not like follow a line or so, and follow a real human. In an actual environment, I mean, you can see the flooring is what the flooring in the hall and so on. So RoboCup at home focus on solving real world problem, and we also deal with real world noise, which means we actually in the rules that we don't define all the furniture, the environment very like up to the dot. Which means, for example, in soccer, the size of the ball, the color of the ball, the size of the field, how thick is the white line, everything is defined accurately. Okay, but in at home, none of this is defined. Okay, like we even have a competition in shopping mall, in restaurant, which is a real environment. So the robot have to go into the real environment, solving real world problem. Like in that environment, you need to follow a person, you need to find a person, you need to talk to someone, provide some services. So these are the objective of this competition, and also the way how it designed it. And I feel that the way how this thing is designed is very suitable for real world problem solving research. Okay, so this is what I want to show you. Right, so, and also over here, the important, very, very important point is the, how to say, we are actually dealing with a lot of noise in real world, okay? So a lot of research, okay? For example, your scientific research, whatever research, okay, it say, okay, so we will switch to the next one. So I'll finish this video, then we'll switch for the next one, okay? So, right, so this RoboCup at home, I maybe want to continue after this, but let me finish this and we'll switch. Okay, so just now we were talking about, real world problem. So a lot of time in scientific research work, we always assume ideal condition, okay, which means no noise, no external disturbance, and so on. But in at home, that is actually the main point, okay? Because in real world, what makes our system fail is not our algorithm, it's not our recognizer calculation and so on, but it's the external factor, the noise around us, the lighting condition, the flooring condition, everything. Okay, for example, like in autonomous car, when it rains, that is the external factor that you can't or you don't put. If let's say you set it in ideal condition, because in ideal condition you don't assume it rains, you don't assume it snow and so on, right? So for at home, having the same concept, we maintain everything in real world and we try to make our robot able to adapt. And the key for this kind of capability, which means your robot is designed, for example, to follow a person. It's able to follow that person in any environment, in supermarket, in your living room, in hospital, in school, and so on. So what makes this robot able to do so with such high flexibility and adaptability is the intelligence. So that's why AI is very important in this development. So for me, when we develop service robot, go back to the first slide that I showed, is we are developing AI application in a robotics way. Okay, right. So I will maybe break for 3 minutes because some of you might want to go to the toilet or take a drinks and so on. So I'll stop here and we will go to the 11 o'clock session, right? Okay, so thank you everyone and we'll see you after this. Okay, and meeting.